My name is Jenna Harrison, and I am a mechanical engineering major.
My name is Chris Begeman, and I am an electrical engineering major.
My name is Claudia Paloma Margalev, and I am an electrical engineering major.
My name is Paul Terwee, and I'm a mechanical engineering major. Our project is the Client Tracking and Monitoring System. We are the first year of a multi-year design aimed to help Lifescape in Sioux Falls better serve and protect their clients. Our project is sponsored by Mr. Jerry Visser and Mr. Dwayne Berman, and our faculty advisor is Dr. Stephen Cheng.
Lifescape provides residential services to clients with disabilities where direct support professionals assist them based on their needs. Because it is impossible to simultaneously monitor every client in this setting, the Client Tracking and Monitoring System will determine which room the client resides in within the facility, as well as detect their approximate location outside of the facility. The system will also monitor the client's heart rate and arm motion to quickly recognize potential emotional needs and health concerns, thus improving the quality of care clients receive. This system will be the first product on the market to incorporate all of these sensors into a single compact device. Sensors will be placed in a water-resistant casing and fastened comfortably on the client's arm. Additionally, the data will go to an Android app and web-based database, where caregivers can continuously view it and respond appropriately. This system will also greatly improve the client's safety and relationship with the caregivers by reducing response time in situations requiring intervention. Moreover, analyzing a client's data history and logged episodes will enable the caregiver to pinpoint triggers and implement methods to avoid them, keeping the client safe and reducing any negative emotions that they may experience.
To monitor the client's heart rate and acceleration, an optical heart monitor and a 3-axis accelerometer were purchased. An Arduino code was generated to read data from both devices. An algorithm was generated to display the acceleration's magnitude, and another algorithm was generated to convert blood flow readings from the heart rate monitor into a human heart rate in beats per minute. Additionally, an HC05 Bluetooth module was purchased to transmit the data. The Arduino code was updated to transmit the heart rate and acceleration data from Bluetooth. The Arduino code receives the data from these devices through an Adafruit Feather M0 Adalogger microcontroller. This data is also stored locally on a micro SD card so that the caregivers can have access to it for later use. These devices were attached to a 400 mAh lithium polymer battery to provide power at all times.
ESP32 Bluetooth Low Energy beacons were purchased for indoor location tracking. These devices are hooked up to a battery and placed in the appropriate room. The phone reads the RSSI signal strength from these devices to determine the nearest device and how far away the client is from that device. The apps were generated in a program called Meet App Inventor 2. This program is a free and open source program that uses object-oriented code blocks that developed under Jobs. The app reads the client's current address through the phone's GPS sensor and connects to the HC05 Bluetooth device to read the heart rate and acceleration signals being transmitted from there. It sorts acceleration and heart rate data based on their value. Using Bluetooth Low Energy, multiple beacons were created for indoor tracking using the HUSA32, which is a microcontroller. When these beacons are within range of the device will determine which is closest and display the room number for the specific beacon.
Data recording begins when a caregiver chooses a client from the New Client screen on the client's phone and presses the Start Data Collection button. The data collected on the client's phone goes to a web-based database, currently Google Firebase, where the data is sorted based upon client, time of transmission, and data type. This data can then be received by the caregiver's phone, where they can view real-time data for all clients. Caregivers can also see an extensive data history within Google Firebase in the micro SD card attached to the device. A heat transfer analysis was also performed to ensure that the electronics do not get too hot inside the device.
The microcontroller and Bluetooth module will be wired together and placed in a watertight casing sealed with flexible filament plugs at the SD card port and the charging port, and an RTV silicone gasket between the two halves. This part will be custom modeled and 3D printed using biodegradable PLA plastic to fit all of the components, and will be secured to the client using single-use plastic event wristbands. These are ideal because single-use wristbands are more sanitary and the client will not be able to remove them, ensuring that they will keep the device on. Custom designs will be engraved on the casing to promote the client wanting to wear the device.
The budget for this project was flexible, but we were asked to stay under $250 if possible. We were able to prove multi-client tracking using a single device at a mere cost of $120.
Since this project will continue for multiple years, we have some recommendations for future years. First off, a new database run by a more secure server should be created and data should be run by that. A more powerful heart rate monitor that is able to make readings in a faster time frame should be implemented so it does not need to be pressed onto the skin as much to work. Additionally, a printed circuit board should eventually be created to make the device much smaller. The app should also be developed further to allow caregivers to enter the client's names without changing them into the code.
This project will greatly improve the quality of care clients at Lifescape receive, and we look forward to hearing about the future design improvements made and how this device is put into practice at Lifescape and potentially other locations in the future.